we'll talk now about our network traffic compatible TDR. I'll explain how it works, what to do with it, what to expect, how to understand indications, and how to connect it to the devices. We'll also explain what is the strategy when we're working with this meter. Again, Quiver can range distance to two types of impairments. One was CPD, that is a nonlinear distortion, and Quiver can scan nonlinear distortion up to the end of the coax through all the amplifiers. It can range microreflection sources, but this is in opposite to the Quiver. CPD radar is limited to the distance between one active and the next active. This is how our TDR will work. Activating the TDR. In the operation menu, we can directly select 3 and enter, or highlight NTC TDR, press enter, and next menu will show up on the screen. Now, left-hand side port is for transmitting TDR signal to the network. The right-hand side port is for receiving return signal containing reflected TX signal. We have 3 options to connect to the devices. Through a QTP20 test probe, and we need to tell the meter that we'll be connecting through the QTP20, or directly to the amplifier if the amplifier has proper connectivity points. The third option is using a splitter to a -20 dB port. What you can do with our TDR. Like with the CPD radar, you can troubleshoot without disconnecting devices in the network as long as you've got access to the necessary ports, or you can put the test probe in. It will show what is the return loss on each device that is between 2 actives. And it will show it on a screen like this. 1 device, 2nd, 3rd, 4th. And each has different return loss. It's intended to be used in the zones of the network that were predefined by a PNM tool. So make sure you've got the starting point from the PNM and understand how the network looks like, because reflections are behaving very special way. How it works in the meter. The meter is transmitting chirp signals that result in a spread spectrum signal below the noise floor or in the noise floor. Typically, it's like more than 40 dBc down. It transmits these chirp pulses, and they are present in the noise floor. And it receives those pulses reflected from the devices in the quiet periods between the QAM signals. When the SC QAMs go down, it will process the signal. It can work sometimes in presence of these QAMs, depending on how many are present. We've had in the past additional item on the menu, blanking, but in this firmware version that you've got now, there is no blanking SC QAMs. It will take care of this by itself. So when you turn on NTC TDR, you will do this only after you've got the starting point and you've got the schematics of the network in between these two amps or amp and fiber node, and to understand what devices are between one and the next amplifier. Will be explained later why. So we select proper connectivity. We then get some measurement result already displayed, but we have to select proper velocity of propagation of the cables that are between these two amps. So from the schematics of the network, you will see on the network map that there is certain type of the trunk cable, and you will enter its velocity of propagation. Just verify what vendor says about this cable, because different cables can have same type marked, but they will be made with slightly different dielectric, and for precise measurements of the distance, this velocity of propagation is important. Just see this indication on this peak. We will enter now 87% of speed of light. It's entered here, and the distance is different by like 100 feet. So longer distances will be indicated with an error if this is not properly selected. The next step is to select proper type of cable. The type of cable will tell the meter how much attenuates that cable per foot, how much attenuates the signal. You see this noise floor line is tilted. This tilting angle depends on the attenuation of that cable type. The more attenuation, the more steep. The less attenuation, the more lean, closer to the flat. We've selected, instead of RG6, cable 650, and it has less attenuation, so we can see it like this. What it means? It means that at the end of the distance scanning range, we'll have more dynamic range in seeing impairment. That's the difference. There is also one more feature. It's called Smart Scale. That is very helpful. We'll talk about how to use it a little later. Connectivity. We connect transmit port to a test port on the amplifier that allows to inject signal opposite direction than you do it for sweep. For sweep, you do it from here to there, but we want it the opposite way, towards direction of the forward signals, where the forward signals going, but in the return band, in the return frequency band. And we'll be listening to the reflections after the return amplifier. Directionality of this port is not very often available on the amplifiers, but some of them do have this directionality, so please check. Don't use the forward test ports for this because they are not suitable, they are other direction. And what it will do, it will send the signal. If the impairment is here, it will reflect the signal and it will be displayed on the screen as a result. If there is no possibility to connect like this, connect to the nearest passive using the QTP20 test probe. And now we'll talk about the smart scale and indications. When the signals are traveling through the network, if these are just taps, the signal drops by like 1 dB on each tap. But when it goes through a splitter, it's different. If we have the impairment just here, it will have this return loss at this particular spot. But because there are these signal level drops one way and on the way back, each of these taps is seen as 2 dB round trip insertion loss. So the indications on the meter, return loss, will be shown better than it really is here. You see, the return loss will be higher and higher the more we go away from this impairment source and we go through more taps. We've got something on the menu that helps to correct for this. If these are just taps, the meter can use smart scale. We turn it on and it will correct this 2 dB and this 2 dB, and if it was this return loss 10, here 10, it will also display 10. Please remember that when you are working with TDR and are checking if something is bad or something is good, in this situation, you will always have good, proper indications. But the meter, although it's very smart, it's not that smart to know that next device, this one, is a splitter. And if we move the impairment after the splitter, it will be different. Everything what is 14, 15 dB and up is really good return loss. So if at one device return loss is like this, here it's only 7, it will show to the meter as much better than it really is, because the round trip here is 6 to it's 8, it's 10 dB difference. So if there was no smart scale, this return loss would look like perfectly good. We've got smart scale that will partially fix this, but only partially, because it thinks that this device are 2 dB insertion loss. But this device to the meter is also 2 dB insertion loss instead of 6. So there is 4 dB offset. And this 4 dB offset will result with 4 dB reading offset. So the measured return loss on a fault located past a splitter will look 4 dB better than it really is. Remember that when you are troubleshooting microreflections, please. Similar situation is on a DC. And one more thing, if we measure return loss from this point, the meter will transmit signal. The signal will go this way and will also go this way. So it will display for you impairment on this side and on this side, like you were scanning from here and you were seeing this one here, but this one will be here and this one will be either atop or a little next to it. So it becomes more difficult to judge what is what. But you will find out how to deal with these situations. This is the difficulty of working with the network compatible device, where you don't need to disconnect everything. because with a traditional one, you would dismantle everything and you would TDR it from one device, and there would be no ambiguity in what is what, if it's behind or it's at the front of me. You will find out how to recognize this. You can also verify on a splitter connecting to the scissor screw on the other side of the ports with this meter in TDR mode and range the impairment. But please remember that TDR has a blind spot next to the 0 up to like around 20 feet. So you will not see anything if it's 20 feet away from you. There are some solutions for this, but please remember that it is like that. Here is a record from a real situation experienced in the field. We were connected with a previous, with a small version of Quiver at the fiber node, and we scanned this stretch of cable plant. At the end of this line, there was a terminator which had only 12.6 dB return loss. All this in between are taps, and they very nicely mark themselves in the proper places everywhere. At the 0, there is a meter calibration point. It calibrates automatically on the first leakage of the TX signal to the input. Again, important to remember that these 2 ports for the forward are no good for connecting. If there is on the amplifier this kind of directionality port where you can inject into the direction of the forward, then you can connect to the amplifier. Otherwise, you use nearest passive. And of course, when using nearest passive, you use another connectivity item on the menu when you turn on the meter. Sometimes amplifiers are equipped with bidirectional resistive test port at the general input of the amplifier. And in this case, you can also scan, but you will use this network. There is in a kit with the Quiver a carefully selected type of a splitter with a 20 dB pad. Please don't lose it. It has specially selected parameters with isolation between these 2 ports that is necessary for proper measurements. So use this, connect, and scan. You will see everything what is before this amplifier. And of course, distances again, and you will search for the problems. If you want to find something right here, you need a launch cable here. These cables are going out of equation because the meter will calibrate itself on this device here, on the leak on this, and it will be the 0 point on the scale. The simplest connectivity is to align passive. There is no need to use the Q amp. So use it. If you would like to measure the length of a cable on a roll, use the splitter, connect, and either it's open end or shorten, it will always show you 0 dB return loss at the very end of the cable. So the peak will go up to the top of the scale. If you want to verify a single device, it's also possible, but you need to use launch cable. The measurements of the length of the cable can go up to 1,280 feet if we talk about the trunk cable types. Measurements are done then with 100 megahertz bandwidth, which offers better accuracy and better resolution than 50 megahertz return. And a single device can be also tested for return loss, but you need to use launch cable. Here is either 50-foot distance or 15 meters. And remember that this launch cable cannot be these two cables, two jumpers, because they will go out of equation. It will be always 0 here. So we can test the device. When testing the single device, remember that all the other ports on this device must be terminated. Otherwise, return loss readings will show poor return loss. It's one of the reason why all the passives should be terminated. And again, strategies like this. You get information from PNM. If there is a group of modems that are suffering from microreflections in between certain amplifiers, that's a good starting point. Go there, you'll be successful. If you don't have that information, do not try to find something, because there will be nothing really to see, and sometimes impedance matching is so good on some connections and devices that they will be really having better return loss than 40 dB and will be not showing up or showing up in the noise floor only. So go to a good place, because there is no fishing in a pool. Here is, again, a summary, what you do step by step. When you will get a copy of this presentation, this is a good summary to go through, and remember that in order to properly use it, you need to understand the network, the schematics. You have to have a good information about starting point, select proper connectivity. More simple alternatives are always passives, first passive after the amp. And if there is indication like 5 dB return loss, then go and simply fix it. If something looks fishy around good values, but you are not sure, well, test it from a closer distance and find out if it's maybe after a splitter or a DC. Remember that when there are many devices, they add insertion loss, and everything looks as better return loss than it is. So using smart scale is a good practice whenever you see multiple peaks. Here is another record of finding real impairment. Here is a cable dent. It caused 5 dB microreflection. You can see negative numbers on the scale, because return loss by math is really a negative number. Equipment vendors are showing positive, just for simple understanding that the higher number, the better return loss is. So we decided also to switch on our scale to positive numbers. You can also try to play with NTC TDR using our meter simulator. Get it from our website, Arcom Digital, in Academy section.